Good morning to all of you, and good afternoon for those in the Eastern time zones. Bhupi knows the Exadata well and was involved with this testing, which you'll hear about later. So he's got a wealth of experience, and you'll hear about that. So all kinds of outrageous claims have been made about the Exadata database machine. Today we're looking at why we can consolidate on Exadata with very good consolidation density. So there's two ideas already, consolidation and density. So let me give you an idea of where we're going. Like a jigsaw puzzle, it's not easy seeing the whole picture, examining the pieces one by one. So if you're not familiar with these topics, you may find it doesn't come together until towards the end of this presentation. If that's the case, hang in there, keep going, and if you have to suspend belief for a while, you're not the only one. The first time I saw an Exadata in action, I really found it hard to believe. We're going to look at where Exadata fits in with Oracle database consolidation and why it's particularly good in this role. This will be backed up with some results from testing, and about half the time will be spent on the architectural picture and underlying theory, and then we'll look at some of the real results from the testing. So I'll just pass over a disclaimer. So let me give you let me give you this picture of the jigsaw. The four topics we're going to look at: the consolidation and database as service. So that's the theoretical side. The Exadata. So just a quick revision of the Exadata machine, and particularly how that relates into consolidation. The testing we carried out, and finally, the so what. Why should that make any difference? There isn't any rocket science in anything we're looking at today. It may be that you haven't thought about things in this way. When you first see it, it might seem like magic, but there are good explanations for what's going on. The principles are fundamentally sound and should be, with a good explanation myself, easy to follow. So, we'll be looking at the high-level architecture for database consolidation and the key things that you'll need to get right if you're going to be successful there. The principle of consolidation is actually relatively simple. Don't do something twice if you can do it once. I've steered away from car analogies, but I'm afraid one slipped in here. So occasionally my wife and I visit our family near Birmingham. It's about 110 miles from our house. You can see the little route there. We've got two cars. We can take both of them. If we go in the same car, we share overheads. The energy needs to move the car, which translates into fuel costs. We can manage with the same music, usually, the aircon settings and so on. So going together, we consolidate our trip into one. It's less work with one driver and has less cost. We can do this because there is enough capacity in the car to get us both there. So we've got a big enough engine, we've got two seats, and we've got an extra large boot or trunk so that Penny can put in lots and lots of bags and things. So if you use systems that have run on their own hardware, ignoring mainframes, but over the years, even the entry-level hardware has become too powerful for many systems. It's a bit like, say, us driving to Birmingham in a supercharged truck just to get the two of us there. So anyway, let's have a look at some of these consolidation models. So the worst case is probably a lot of dedicated servers with storage for each system. There have been lots of spare capacity. This is like us taking a couple of cars on a trip. It's just too much. The sweet spot for small servers is typically being 2 sockets with 4 or 6 cores. But when your system only needs 2 cores or even 1 core, then it's too much. So consolidation isn't a new idea. Most high-end or mature users of IT have had storage area networks for a while. That's just consolidating disk. And there's probably some kind of shared hardware for, say, development. What we're looking at now is more an integrated approach for the Oracle database. There are some key and important differentiators with the Exadata. We'll come back to those. But the basic premise of consolidation is if we run a number of systems instead of one on some hardware, it costs less, and is more efficient in terms of time, people, hardware, software licensing costs. Some things that motivate us towards consolidation are it's easy to manage with few moving parts. We hope it will save capital and operational costs, free up time for high added value activities, which is where we want to be. So we continue this pitch with the consolidation models. The first one which you've seen a lot of, and which you're probably very familiar with, is using the available capacity with some common overheads. A first step is often infrastructure consolidation. We keep running the same number of copies of the operating system, but sometimes copies will be sharing the same hardware. This can be very successful. However, it can bring its own vices. Explosion of development copies is common. It's increasing rather than reducing the operational management workload. So you're getting more to do with all these copies of the operating system. Where databases are concerned, the duplication of the operating system is a waste of server resources. It's better keeping the number of operating systems down by running multiple databases on a single copy, and that's a dedicated database approach. We can further reduce the overheads by running fewer databases with a number of applications sharing them. So here we've got a picture of a shared database. So this could be using, with 11G, that could be a schema for each application. With 12C, this could be the multi-tenant approach where we have pluggable databases. In this testing, we were pre-12C multi-tenant, so I'm presenting to you what we found from that testing is completely relevant to the 12C approach, but we will be focusing on the dedicated database model that you see on this picture here. A final thought I'd like to leave you is that this topic of consolidation and database as service are often seen as two sides of the same coin. So I'd suggest that the database as a service is the next step after the consolidation. So my simple view is database as a service removes the notion of where a database is running. All you want is a service with some service characteristics and an operational environment for managing it. As operations, you do care, but as a database user, it doesn't matter. As an application developer, all you're saying is, oh, I want a connect string and a service name. And again, as an application developer, you don't care where the database is. So far, I've avoided a very important topic, which leads into why Exadata is very good for consolidation. We need to get the hygiene factors right. So I've borrowed this idea of hygiene factors from Hertzberg's motivational theory, but it's very simple. These are the things you don't notice if they're okay, if you've got them right, but everyone knows if they're not. So very simple example, have you got enough parking space at your office? Are there enough power sockets for your PC or laptop and phone on your desk? If you get them right, no one notices. If you get them wrong, it's painful. So an important hygiene factor that must be right for consolidation is having enough resource available to the job in hand. So when systems are consolidated, they will share resources. As long as there are enough resources, everyone is happy. So let's have a look at what that means. Let's say we have a couple of applications we want to consolidate. We look at the workload, see how much resource they need, and see whether they could be good tenants. In this case, it looks like they could live together in harmony. Maybe a little bit cramped, but just about. So let's try another pair of systems. In their case, so in this case here, they need more resources than the consolidation platform can provide. This is not going to work well. So this will be starting to break a hygiene factor around performance. It's going to get noticed. So if you've made some attempts at consolidation and you've heard things like, when we had our own server, it wasn't like this, that's a hygiene factor not being met. So there are really 5 primary resources that we need to balance if systems are going to share nicely on a consolidated platform. That's the CPU, the memory, I/O, network storage, and you've got to have enough space. Now, what I'm about to say is very important to understand and underpins the rest of what we're presenting today. For a database that persists its data to disk, so I'm not talking about memory databases, so a database that persists to disk, including Oracle, the most common limiting resource is I/O. So I've just lost focus to move slide. There you go. So over the years, CPU power, RAM, network speed, static storage have all increased at significant rates, broadly keeping up Moore's law. The one missing is the disk I/O. These speeds have been static, 15,000 rounds per minute, RPM. That hasn't changed much, or 7,000. We're not suddenly moving to 70,000 or 700,000. It's pretty static. So if, like me, you've looked at large Oracle databases, you will know that very soon you often find that I/O is the problem child. And this is where the Exadata has major advantages. For consolidation to work, there's plenty of work to be done. But if we know the I/O has been a limiting factor, whatever else happens, it must be managed. So the other thing we've got to do is care for the resources. So if everyone plays nicely, then you can share. It's a bit like school. If you get just one idiot, everyone suffers the consequences. And these are the resources we mentioned earlier, the hardware, the CPU, the memory, the I/O, the network, and the storage. So here's a couple of other topics that you'll need to think about if you're doing consolidation. So resource management, we talked about that, some good capacity planning, making sure you've got enough for everyone to share. But also you need to plan for regular updates, and possibly with some service continuity, now having many more databases running the same hardware. Probably some automation of the testing. So there may be application testing, or if you've got a database, you can use real application testing to replay a workload and make sure that your upgrades are going to work happily. And standardization. So standardization would be around things like the sort of service you provide. Typically it might be given names like bronze, silver, gold, or in business terms they might be mission critical, business critical, day business, non-critical. But a standardization so that you can reduce the effort needed to get your databases managed. So just to wrap up this little piece, database as a service is that step beyond consolidation. And here are some of the primary drivers that we see around database as a service. There's cost savings through consolidation, some kind of showback or chargeback. And the idea here is that once you share the database platform amongst many, many projects and bigger departments, you might want to show how much of that they're using, and then maybe even at some point charge back so that people are aware of what they're asking for and using. And this can be used as IT, this can be used as a good lever for putting some good IT disciplines into the final sort of user systems, the business users. Probably some easy to use self-service portal. So particularly in things like development, allows developers within their resource plans to maybe run up a database, drop a database, start another one, a particular version, and having some easy way to return these resources to the resource pool when they finish with it. But one thing that's very useful here is that what I found is that the Exadata is less sensitive, because of this I/O characteristic, is less sensitive to where you place your databases. So it does make it a lot easier to make these things self-service. So instead of having a big process to go through to decide where to put something, you say, yep, I'm going to put it on, and I'll put it on there, fine, move on, next database. So the key things you should carry over from this section into the next one are I/O is typically the limiting factor. If you get the resources and the resource management wrong, SLAs will be missed and your users will be very unhappy. So now we're going to have a look at the Exadata, and I'll hand over to Bhupi at this point, and he'll take you through an appreciation, just high-level appreciation of the Exadata and how it works in this situation. Over to you, Bhupi.
Thanks, Alastair. We will now be looking into Exadata at a very high level and see how it provides best platform for the database consolidation. So moving into this slide,
Just bring the slide up, sorry.
we could talk about Exadata for many hours in great detail. So this will be a very cursory view. There are perhaps 3 or 4 thoughts I would like you to take away from this section. The first one is how Exadata deals with the I/O, which we have seen is the most limiting factor in the database consolidation, and how Exadata has a database-aware resource management for all other resources. So Exadata is from an Oracle's family of engineered systems. Just before we get into some of the detail, I'll just spend a moment what we mean by engineered. Engineering is putting hardware and the platform software together so that they behave more consistently, reliably, performing and scaling. Doing it well is hard and time consuming. It can take a team months to get this right. And so Oracle has done it for you. As we can see on the slide on the right, we have a custom configuration. So to make this custom configuration, one has to spend lots of time that goes in months, where we have to assemble lots of components. It can be a dozen of components, drivers, compatibility matrices, OS version, database versions, hardware, software matrices, and so on. And on top of that, one has to do a testing and debugging of the platform to make sure that it is good to serve as a platform for the database. Whereas on the left-hand side, we can see that this can be done easily with the Exadata, where you have your platform already up and running with desired level of performance within days. With Exadata, you are getting a highly standardized system. We can get high level of support because we know all the components, software, firmware, top to bottom. So if there will be any problem, we will be able to fix it very quickly. So moving ahead into a physical components of Exadata, I'm going to talk about here technical specification numbers. So if this is not your particular area, you can just gloss over them. But the key idea to take away from this slide is these numbers are really large, and here large means good. So Exadata is a set of standard servers configured in a standard configured rack. So servers is the components basically made of a database servers that you are familiar with and the storage cells where the database disks are. The whole lot of thing is connected through an InfiniBand. So let's have a look at the compute nodes. So on the slide, you can see the things highlighted in red are our database servers. And then we have storage cells. Storage cells are small 2-unit servers with 12 disks, 4 flash memory cards, and some RAM. In other words, a server with 12 disks for the database storage, a lot of flash, and a lot of compute power. What I'm telling you now is the huge technical difference between Exadata and a conventional platform. What we have done is make the storage database aware. So you can offload a lot of database processing on the storage and get that done at the storage level itself. This is how we address the I/O data rate problem. And the last component here is the InfiniBand path between each server and each storage cell, which is around 80 gigs per second. So this I/O is also very capable. So the path between the disks and the database servers can supply data faster than the servers can ingest it. So this is the key takeaway that how Exadata is handling I/O problem. Moving ahead, we can look at that how Exadata provides best performance at the lowest cost. Oracle Exadata provides this with multi-tiered optimized storage approach. Exadata provides the benefits at all levels by providing us the cost of disks, IOs of flash, and speed of DRAM. So as we can see on the slide, we put majority of our data on the disk, but the warm data, which has been queried regularly, is pushed on flash, and which is the hot data, which is the most frequent access data, will be put in the DRAM. So with this multi-tiered optimized storage technology, Oracle offers you best performance at the lowest cost. And the last but not the least is the real secret sauce, which is Exadata Intelligent Storage. This makes Exadata really different from anything else out there. The technologies available within Exadata storage like hybrid columnar compression, which can help to significantly lower your storage cost by the factor of 10x to the 50x. Exadata Smart Flash Cache, which enables extreme performance for the OLTP workloads. It's a write-back flash cache, so you can put the writes also through the cache. And the Smart Scan, which improves query performance for the data warehousing sort of workloads by pushing the processing at the storage level, which we have seen in the first slide. Exadata storage is also scale-out parallel architecture with no bottlenecks to limit aggregate throughput. The result of engineering the hardware and software together between the database and storage is very fundamental. That's what gives us the I/O capability and the performance. The kind of the things that we can do in Exadata storage are listed below. So it's like the query filtering, the query joins, projection filtering where we want to see only some columns of the data, encryption, and the most important I/O prioritization. What we are doing is taking the processing to the data. It reduces the I/O sent back to the database server, reducing its CPU needs as well. What we have is a high data rate pathway, which is faster than the CPU can ingest the data. So if you see it, it's a double win. We are keeping the data transported kept down to the storage cell operation and keeping it less to travel up. Let's see how Exadata handles the most limiting aspect of database consolidation, which is I/O. So the most important feature of consolidation is I/O is resource managed. So we can see on the top that how traditional storage servers handle the I/O request. So the database sends the I/O request to the storage server and they put it into the queue of the disk. Database, so we have no I/O prioritization or absolutely no application tagging to signal what is priority from the business perspective in a traditional server. But now in Exadata, we can see that I/O Resource Manager is fully aware of the business level priority that is implemented along the DB consumer groups. Here we have seen that the priority has been set, so we can differentiate the data into a high priority and a low priority, and that will be implemented with the Database Resource Manager, which is well coupled with Oracle Database. And with this fully aware business priority, the I/O Resource Manager is now smart enough to prioritize the business work over the low priority work. This is unique to Exadata and thus provides fully database-aware storage I/O subsystem for the database consolidation platform. So to sum up, we have a comprehensive resource management. Oracle Exadata provides this comprehensive resource management at all the three levels, be it CPU, network, as well as I/O. A simple statement and easily mixed, but unique to Exadata is this is so important for good resource sharing when we talk about consolidation of databases. And on top of that, the flash, as I told, can be used for both read and write. This gives phenomenal speed. The scalable unit of cell along with ID, flash, and disk mean Exadata can handle the mixed workloads, be it OLTP and warehouse workloads. In the results from the testing, you will be seeing that reporting is working alongside the OLTP without tripping up or one killing each other. We will see the same in the results of the next section. With that, I will pass it back to Alastair to walk us through the test.
Okay, thanks, Bhupi. So there, a little bit of a dive into the Exadata, and that's giving us a picture as to that there are some real, very good technical reasons why the Exadata is good at the I/O side of the picture. So now coming into some of the tests, I explained what the tests were, how we set them up, what we expected as results, that's always good to know, and the final picture. These tests were carried out with one of our customers in the UK. The test looked at comparing standard disk-based architecture and Exadata. We're using their standard sort of internally engineered configuration as their standard building block. So if they weren't using Exadata, this is what they would be using instead. So it's probably not that dissimilar to something you might have. So the servers had a similar CPU and RAM capacity. In fact, there are a few more cores on their servers. And they were connecting to their SAN using fabric, using fiber, a fiber fabric. So we didn't try to actually equalize all the capacity because our rationale was looking at the standard build, comparing that with Exadata, but they're very sort of similar in their sort of size. So going back to the earlier comment on I/O as a general rule, I found these systems lacking in I/O for the available compute power. So a quick revision of what we expect. On conventional hardware architecture, without the Exadata magic, I/O will usually be limiting. The way we examine this effect by looking at average query response times. And we did some key randomization to make sure we're always getting a little bit of I/O as well. Otherwise, if just in memory, that wouldn't really help us. So just to explain this, the curve you're about to see shows what happens when the load increases on a limited resource. It could be CPU, could be disk, could be I/O. This is what happens. Along the horizontal with how much is being done, and vertically how slow the response is. So the higher, the worse it is. At first, the I/O can handle the load, and the response stays pretty flat. At some point, I/O requests start to come faster towards the disks because of the increased workload. But occasionally, I/O has to wait. It's sometimes in a queue, on average not very often, but on average you start to see a bit of a delay. As it gets more busy, it comes to a point where the average length of the queue gets longer and longer, and it all starts to take a while, and eventually the requests arriving so fast, the response time falls away dramatically, and you've probably heard of the hockey stick, and you may have experienced it, and mathematically that's what it looks like. So eventually, even though you might be getting up towards your capacity, it's really slowing down. So what we expected to find in the test is summarized on this next slide. We expect to find that on conventional hardware, the limiting resource will be the I/O. So at some workload, say number 2-ish, this is going to it's going to run out of capacity, response time is going to climb, and it's just not going to work for us. What we expect to find on the Exadata is that because we can deal with the I/O, we actually have the CPU as a limiting resource, and we expect to get to much higher workload. So that's what we're expecting, and I was pleased to say it did look a bit like that in the end. So in terms of the testing, we had a full machine available to us, but we used half of it with high-capacity disks. We had a similar compute on the SAN, and we measured the throughput and response of OLTP transactions and ran concurrently a number of reports. So we always had some reports running at the same time. We collected report results, but the important thing that told us what was happening was the response and throughput of the OLTP queries. So we created a number of databases to do this testing, in fact about 100. There's, you see, a variety of sizes. A lot of them are around about 20 gigabytes, but we did put in some larger ones and a couple of 1 terabyte databases. So these would have randomized access across the data sets. So we really are going to show this is not just something that works for tiny databases. So what we had to do then was, having decided the size of the databases, which was based on profiling the databases that we're using, we then had to decide what sort of load we're going to have. So we did a survey and tried to sort of characterize the different types of databases, and we plotted a scattergram of CPU and I/O usage. And I've put on a slide there just to show you that there isn't just one figure, and these do spread out a lot. So we did a little bit of projection on that and best fits, and came up with two characteristics that would drive our load, so that for the development, it'd be a little bit more CPU, a bit less IOPS, and for the production load, in fact that says UAT, but that's because we found UATs more heavily loaded. You'll find that there's a bit more I/O going on. And we created a profile within SwingBench, our load generation tool, to match that sort of picture you see on the graph there. So so let's go and have a look at what this actually looks like. So there we are. This is the magic result. Now hopefully you might see something that looks a bit like the graph we saw at the beginning. And what we're seeing there on the left-hand side is that, I'll just explain the graph actually. The little circles are individual 15-second measurements, so very small point-in-time measurements. And the bigger circles are from some averages we took out of AWR reporting. So what we found was that the conventional hardware was very much starting to run out of capacity quite early on. So we just wait for the slide build. There we are. So there's a significant degradation and spreading of responses, and once you got to that point, it's about half the CPU is used, but half the time is in I/O wait. So really the system was not going anywhere further. Whereas we saw with the Exadata, there are a few outliners you see from cache warming as we ramp up the test, but on the whole it's pretty flat and just starting to see a little bit of spread right up at the higher end. So what we're seeing on this graph is we are running 7 to 8 development databases on the conventional hardware and about 70 databases on the Exadata, and that was on one compute node. So, and we ran this with a soak test over a number of hours, so this was looking stable over that period. So what that's given us, that's showing that we were getting some density somewhere around, we were able to support about 10 times as many of these development databases as we were on the conventional hardware. So in that respect, the effect of the I/O is impressive, and the response time is consistent right to the end of the test. So we did the same thing for the production load as well, and here again we found a similar sort of pattern, that once we got to 4 to 5 databases on the conventional hardware, it was starting to degrade significantly, and we're comparing a 10 millisecond, 8 millisecond response time with about half a millisecond on the Exadata. And you can see that actually the Exadata continues flat. Each of those blobs represents adding another production database. And just to give you a picture of what this means, those 16 databases were running a load that's equivalent to something like everybody in the country buying something from Amazon that day. So it's not an insignificant workload. So here we're seeing, even for production, we're still getting a better density. And so what we found from our testing is that, as we expected, the I/O runs out early on conventional, which means that you can't use the CPUs and the performance degrades, but on the Exadata it stays much flatter for much longer, and that's why we're able to run more databases. So I'll just let Bhupi sort of wrap up for us, and he's going to sort of finally close down with the so what. So Bhupi?
Thanks, Alastair. So now we have looked at the technical details and observed that Exadata provides the right profile for the database consolidation density. So what this translates to? It translates that Exadata is engineered to simplify your IT. As we can see on the slide, the typical database environment hosting huge number of databases across numerous servers can be replaced by a small number of standardized Exadata database machines, providing platform for the database consolidation to handle mixed workload as well as business priority. At the same time, providing highest level of availability, security, and support level, along with one end-to-end management solution for the whole environment. So this gives you the best-in-class database consolidation platform. So moving ahead, what this translates to in terms of business benefits. So we can categorize into three aspects. So first one is lower total cost of ownership, business agility, and reduced risk. So first is the shifting cost to the profits, thereby lowering total cost of ownership. As consolidation offers standardization and thus simplicity to deploy and manage, it results into a lower total cost of ownership. With this cost saving, businesses can shift the budgets to the new projects or support more clients or the business. The second one is the business agility by improving time to value. As we have seen earlier, with Oracle Exadata, which is pre-configured engineered system, one can dramatically reduce the time to market from months to days. With consolidation and configuring the database as a service on top of it, one can offer the self-service provisioning, which is a rapid real-time provisioning of the databases to cater to the project needs, thereby supporting the dynamic business requirement. So you can beat your go-live dates by months, not days, and add the business capabilities as business needs. The last one is the reduced risk. It not only shortens the total time of value, but it also reduces the risk because the Exadata is delivered as an engineered system which is pre-tuned as a unit. It provides a risk-free platform, thereby ensuring system stability and the highest level of support for the business continuity. So this provides you all the business benefits in terms of database consolidation. With that, we would like to open for questions.
So just give you a moment. There might be something that you're not sure about, likes to go over again, or got some questions about testing or the Exadata machine itself. So feel free to ask a question. The easiest way is send it in the chat, and we'll take those questions, give an answer, hopefully give you an answer. Okay, I've had a question here, which is, with the 12C multi-tenant option, does that make any difference since we did our testing on 11G? We were using the database consolidated model where we have a number of databases running on the same operating system, the same hardware. With the multi-tenant version of the database, you get some more resource saving in that there are more shared resources. So where this make a difference in particular is if you have those overlapping workload profiles where resources could be used by one database and then another database, then 12c mobs tend to be very good in that kind of environment. There are shared resources such as one database writer, for the container database that works for the contained or pluggable databases. And there are operational management goodies that come with it as well. I'm just seeing another question coming through. So cost savings, so could I say something about cost savings in terms of licensing benefits? Okay. So in terms of the licensing benefits, I think the key thing that we're seeing there is that essentially the core count is coming down and dramatically in many cases. I've worked on projects where we've seen literally hundreds of databases consolidated, and people like Gartner also have noted this, that often if you look at aggregate across the whole of an estate, you might only be using 10, 15% of the available capacity, but that's all being paid for with licenses. So one of the things that will happen is that the license cost has the potential to come down with fewer CPUs, especially as on the database license from Oracle tends to follow a CPU pattern. I've got another one. It appears that I/O was never an issue on the Exadata. Is it over-engineered and therefore couldn't we just use SSD-based SAN to get similar benefits? I think what we are seeing is a bit of, with the Exadata, some of the OLT performance is no doubt coming out of SSD, but there are some key differences with the Exadata, and one of the big ones is that we have a very fat pipe connecting the SAN up to the database. So what we're seeing there is every 12 disks has 80 gigabits of connectivity to each compute node. It's through a switch, and each compute node can communicate with each 12 disks at that rate. So we're definitely able to pass data very, very quickly. So we're talking about terabits. That's 100 gigabytes a second is the sort of, 200 gigabytes a second, that's the sort of capability of the infrastructure. So what it means is we can actually feed the CPUs as fast as they can take data. But the other thing is that we've also got the software actually running in the storage. And even for LTP systems, this can make a difference. So we've got smart Oracle software running in the storage. In fact, we've got more compute power in the storage than we actually have in the database servers. So that's where you get a huge benefit. And the thing that I tend to find also is that, Bhupi mentioned the sort of relative costs. So because we've got smart caching, we can still keep a lot of data on disk, which is still much cheaper than SSDs, but we don't lose that performance characteristic of an SSD. So overall, we get a much more balanced environment. And I'll just say finally, we very rarely find pure OLTP workloads. There typically is always a bit of reporting going on, and that's where the smart software itself also really comes into its own and can make dramatic improvements, and thereby freeing up more of that I/O that is used for the OLTP type applications. I'm just looking to see if there's any more questions coming through, or are there any supplementary questions? I'll just wait a minute on that. Okay, well, I'd just like to say thank you for your time, and I hope you found that interesting and give you a picture of the Exadata and some good scientific technical reasons why it does work well for consolidation. Natalie, is there anything else that you need to say at this point? Do we just close this down now?
Well, just to say thanks both to you, Alastair, and to Bhupi for a great presentation again. Thank you very much. And just to say that this webcast is being recorded and we'll be posting it on YouTube and the Oracle Learning Library. So if you don't know what the Oracle Learning Library is, go to Google and just Google Oracle Learning Library. You'll soon get to the website. So it's part of the Oracle Technology Network. And so this webcast has been recorded and posted up there and also on the Oracle Learning Library YouTube channel. So you can have a look on there in just a couple of days' time.